Welcome. We are going to talk in this video about surface area and volume of some fairly basic three-dimensional objects. The first one we're going to look at is a rectangular prism. And that rectangular prism, here's a picture of one, is just a box. It is a box. And with what we're going to do, we're going to assume that it has 6 faces. So there's this one. There's another one the same size over here. There is this one in the back. And if I label these as L for length, W for width, and H for height, notice the two that I have here in blue. Those are going to be area W times H. There's my W times H right there. But I have 2 of those. And then the one that's outlined in red in the back and the one that's outlined in red here in the front, that's L times H for the area. And I have 2 of those. There's the 2. And there's the L times H. And then the top and the bottom, notice the bottom rectangle is length times width. There's my L times W. So it's pretty straightforward where these come from. And that's the surface area, is the area of all 6 of those faces. Now you just have to read problems carefully. If we have a box without a top, then the surface area would be a little bit less than that, or the amount of material needed would be a little bit less than that. So read problems very carefully. The volume and surface area, remember area is measured in square units. So this is going to be measured in square units or units squared. But volume is going to be labeled with cubic units. So maybe centimeters cubed or inches cubed or cubic yards. Volume is the amount of space inside the boundaries of that three-dimensional object, the amount of space that is taken up. And notice if we did length times width times height, if these were inches, I'd have inches times inches times inches would be inches cubed. So volume is in cubic units. Keep that in mind. And the rectangular prism is really easy. Length times width times height to calculate the volume. The cube is like the rectangular prism, but all 3 of the dimensions are the same. The length, the width, and the height are all the same. Notice these are all the same. So the formula for surface area becomes 6a squared. I have 6 faces on that cube, and all of them are a times a, or a squared. The volume, the length and the width and height are all the same, so length times width times height becomes a times a times a, which is a cubed, because they're all the same. All right, let's look at the cylinder. The cylinder has a circular top. So this is a circular top. It has a circular bottom, so the bottom is exactly the same size. So the top and the bottom are both circles with a radius of r. So notice that their area of the bottom and the top are both pi r squared. So I have 2 pi r squared for the area of the top plus the bottom, pi r squared twice. And then we also have, if we were to cut, let's see, if we were to take this, let's say it didn't have a top and a bottom, and we cut right here, and we unrolled it, we'd have a rectangle, and that rectangle would be this, and the circumference of the circle would be the other dimension. So we get the 2 pi r each. Okay, so the surface area of the cylinder, 2 pi r squared plus 2 pi r h. That's assuming that we have a top and a bottom on that cylinder. So if we needed to know how much material we needed to create an object like this that had a top and a bottom, we would use this formula. Okay, volume is pi r squared times h. And then for the cone, and we could draw our cone this way as well. Maybe it goes like this. It has a circular base So whether we draw it this way or the other orientation where it's sitting on its tip like that. Surface area, well, what we need is we need another label here. So I have a right triangle. This is a right circular cone. It's sometimes referred to as a right circular cone because we have a right angle created by the segment that goes from the vertex here down to the center of the circle. It makes a right angle, a right circular cone because the base is a circle. Well, we have then this length L, and that's sometimes called the slant height. That's an L. There's an L right here in the formula for surface area. Surface area is calculated by doing pi r squared, which is the area of the base, and then adding what we call the lateral area. So this is referred to as the lateral area. Okay, lateral, or sides of that cone. Can you really call it sides? Anyway, the lateral area. It's the area of the cone without the circular base. And the L is called the slant height. L is the slant height. Now notice that slant height, if we look at that right triangle and use the Pythagorean theorem, L squared equals R squared plus H squared. So that lateral, or that slant height, is easy to calculate if we have the R and the H. And then the volume for that cone is 1/3 pi r squared H. There's the formula. We'll refer back to these as we get into some examples. For a sphere, I don't think you can see them probably in your note packet, so I'm going to draw them a little bit bolder. So there's a diameter of the sphere. That's D for diameter. And then in green, I'm going to draw a radius. Okay. Remember, the radius is always half the diameter. So if I need the radius, I can take the diameter and chop it in half. All right. The surface area is 4 pi r squared, and the volume is 4/3 pi r cubed. I'm just going to use those formulas, not even talk about where they come from. So let's dive into some examples. Find the surface area and volume of each figure. So here we go. Surface area. I'll use SA for surface area, just like we did on the other side. Assuming that we have a rectangular prism here, the surface area is going to be 2 times, we'll do 5 times 12, plus 5 times 3, plus 3 times 12, or 12 times 3. Okay, so I've got 2 of these. That's the 5 by 3. I've got 2 of these. This is the 3 by 12. And then I have 2 of these, which are the 5 by 12s. Okay? And then we just multiply it out. And we'll just grab our calculator and do the math. You can have your calculator do it all at once if you want. And I'm just going to let you grab your calculator and do that. And you can compare your answer with mine. That is 222 square inches. That's our total surface area. And then for the volume, we'll do V for volume. The volume is going to be really easy. It's 3 times 5 times 12, length times width times height. Multiply them in whatever order you want, and that when we grab a calculator, multiply that out, that's going to come out to 180 cubic inches, or inches cubed. And it's just that easy. Okay, for example 2, what we have is a cube. Surface area of the cube is going to be 6 times side length squared, not squared, cubed. No, squared, because it's area. Each one of these faces is a 5 by 5. Okay, so the area of one of them is 5 times 5, or 5 squared, but I have 6 faces of that cube. So the surface area is going to be 6 times 5 squared. Grab your calculator, do the math. What's 6 times 5 squared? Comes out to 150, and we don't have any units on that. So if we want, we can write units squared, or we can just leave it as 150, but it would be square units, 150 square units. Let me make that 5 look a little bit better. And there we go. Okay, volume. Let's do a volume. The volume of this is going to be 5 times 5 times 5, or 5 cubed. Length and width and height are all the same, and that is 125 units cubed. All right. Example 3. You notice it's just a matter of using the formulas, making sure you have the numbers in the right places in the formulas. So this is going to be the height of our cylinder. This one's a cylinder. The radius of our cylinder is 25. Radius is up here. So we go back and we look at our formulas and the formula for surface area. So we're going to assume that we have a top and a bottom. So we have 2 pi r squared, but r is 25. And then we have 2 pi rh is the other part of the formula. So 2 pi r and h. Formula for surface area. 2 pi r squared plus 2 pi rh, and then we just plug the numbers in. All right, and then we're going to do some quick calculations here. 2 times 25 squared is 1,250. 25 times 2 times 40 is 2,000. Notice there's a pi with each of those. So I'm going to get an exact answer. My exact answer is going to be 3,250 times pi. And that would be cubic inches. And then for a decimal approximation for this, we grab our calculator, we do 3,250 times pi, and we're going to come out with 10,210.18. And I wrote inches cubed, but this is area, so I need to go back and I need to fix this. It is not cubic inches, it is square inches. It's area. Area is in square inches. Okay, so let's make sure we fix that. It is square inches. Now we're going to do the volume. So V for volume. I'll change colors here because I'm getting tired of the blue. Volume is going to be pi r squared. R is 25. So there's my pi r squared, and then I have to multiply by h, which is my 40. And I'm going to come up with 25 squared times 40. That's big. That's 25,000. So that's 25,000 times pi. And that's going to be, now we have cubic inches, or inches cubed. And that is approximately, so we'll grab our calculator. We'll do 25,000 times pi. That's going to be 78,539.82 cubic inches. All right, example 4. In order to find the surface area, I'm going to have the slant height. So I'm going to do L for the slant height. Here's the height of the cone. The slant height, I'm going to need that for the lateral surface area. And this is the radius. So for surface area, let me calculate our L first. L squared is r squared plus h squared. So we do a little math to that. We get 100 plus 625, that's 725. So L is the square root of 725. If you needed to simplify that, you could make it 5 times the square root of 29, if you need to simplify it. So read directions carefully. Do they want exact answers? Do they want simplified radicals? Do we just need decimal approximations? Don't do the simplifying the radical unless you really need to. Okay, now we have the ingredients we need for surface area. Surface area of the cone. It's going to be pi r squared. So pi times 10 squared plus The lateral surface area is, what is the lateral surface area? Pi times r times L. So we'll do pi. I actually flip back, look at your formula. Right, formulas are right here. For the cone, the lateral area is pi r L, lateral area. Okay, so we do pi times r times L, which is our square root of 725, or we could put in 5 times the square root of 29 if we needed to. And we could do some simplifying there if we need to. But we're not going to be able to put these things together because this, the 100 that's a coefficient of pi here, we've got this square root of 725 that gets in the way. So I'm just going to grab a calculator at this point, and I'm going to type in all those numbers. I'm just going to do it 100 times pi plus, what did we have? 10 times pi times the square root of 725, and we'll get our decimal approximation, 1,160.06 if I'm rounding it to 2 decimal places. Okay, so our surface area is approximately, we did round it off, 1,160.06 centimeters squared, square centimeters. And then we'll do the volume really quick. So our volume, look back at your formula, volume of a right circular cone is going to be 1/3 pi r squared. So the volume is 1/3 pi r squared. So we'll do pi times the radius squared. Did I put in an h? Pi r squared h? Maybe when I said it a second ago, I didn't say 1/3 pi r squared h. It's 1/3 times pi times r squared times h. Okay, there's where we're going to get our centimeters cubed. So we've got centimeters times centimeters times centimeters, which is centimeters cubed. Okay, we're going to simplify that a bit. Volume equals 10 squared is 100. 100 times 25 is 2,500. So we've got 2,500 pi divided by 3. Remember, multiplying by 1/3 is the same as dividing by 3. And this is going to be an exact answer. So if you need an exact answer, there's a nice one. If you need a decimal approximation, you grab your calculator and you come up with a decimal approximation. And we're going to get out of this one 2,617.99. So basically 2,618 cubic centimeters. And that is the end of that example. Okay, the next one we're going to take a look at is this last example 5. Let me go up just a little bit. So I want you to make sure that as you're looking at your notes, you recognize that this segment goes all the way across. So I'm going to assume that the 18 represents the diameter. See that little 18 right there? That's the diameter. So if the diameter is 18, that would mean the radius is half of that, so it's 9. Okay? If they had meant that the radius was 18, they would have stopped that segment at the center of the sphere. So on this sphere, the radius is 9. And our surface area and volume are pretty straightforward formulas. Surface area is going to be 4 pi r squared. Radius is 9, so 4 pi times 9 squared. We'll do a little simplifying. For our surface area, we have, what's 9 times 9? 81. We can grab a calculator. 4 times 9 squared. That's 4 times 81, which is 324. Okay. 81 times 4. 324 pi would be the exact answer. We don't have units on this, so the best we can do is units squared. And then if we needed a decimal approximation, we grab our calculator, we do 324 times pi, and we get that that's approximately 1017.88 square units. Its area, so it's square units. And then the last thing we will do is we will calculate the volume of this. Wherever you have room, if you need to move over here, then we can certainly move over here. The volume of the sphere, this is for our sphere. The volume is going to be 4/3 pi times the radius cubed. 4/3 pi r cubed, that's our formula for volume of a sphere. So we take 4/3 times pi, and then we multiply that with the cube of the radius. 4/3 pi r cubed. And then we'll simplify that. 9 cubed. Well, 9 definitely has a 3 in it, so I can divide a 3 out of that. But I have to do the cubing first. Remember, order of operations. So I'm going to do 9 cubed, which is 729. I'm going to divide that by 3. That's 243. I mean, whatever you need to do here. That's 729, that 9 cubed. I can divide by the 3 because, well, the 3 is in the denominator. 729 divided by 3 is 243. And multiply that by 4. It's 972 pi. No denominator left because the 3 divided evenly. So our volume, if I needed an exact answer, 972 pi cubic units. Units cubed. Okay? Cubic units. And then, if we need a decimal approximation, we grab our calculator, we do 972 times pi, we get that that is approximately 3,053.63 cubic units. And that is surface area and volume.